Kita udah live. Oke, kita udah live. Selamat malam teman-teman. Selamat malam dan selamat datang di Kubernetes Cloud Native Online Meetup di bulan Februari ini tahun 2022. Terima kasih buat teman-teman yang udah datang. Ya langsung aja kita mulai untuk acaranya. First agenda kita pada malam ini, pertama ada Kubernetes Community Update. Lalu untuk talk pertama dari Srinivasa Vasu dari Yugabyte. Lalu untuk talk kedua dari Akbar atau Pak Akbar dari Fliptech. Lalu terakhir kita ada Q&A. Dan yang terakhir bakal ada beberapa announcement. Jadi buat teman-teman ketika talk berlangsung bisa langsung aja buat tanya di kolom komentar. Kemudian tapi bakal kita jawab pada saat Q&A. Jadi langsung feel free aja buat tanya langsung di kolom komentar. Pertama untuk update from Kubernetes or Cloud Native Indonesia. Pertama untuk previous meetup. Jadi untuk previous meetup udah bisa teman-teman akses untuk slide-nya. Itu ada di GitHub kita, yaitu ada di Cloud Native ID. Dan teman-teman bisa langsung cek aja ke sana. Itu udah ada semua meetup kita, itu udah ada di sana dari meetup yang pertama yang dulu masih offline sampai yang terakhir kemarin di bulan September kalau nggak salah. Itu ada semua. Jadi teman-teman kalau misalkan mau lihat untuk slide-nya bisa langsung aja ke Cloud Native ID dan itu di repo Meetups. Untuk yang last online Meetup itu kita ada di bulan September dan untuk videonya juga teman-teman udah bisa langsung cek aja di YouTube ya buat videonya. Dan itu pun di YouTube kita lengkap dari yang last sampai yang kemarin event KCD atau Kubernetes Community Day itu udah ada semua. Jadi teman-teman bisa langsung cek aja di kanal YouTube kita. Lalu untuk community update, bentar lagi ini bakal ada KubeCon atau Cloud Native Con Europe 2022 collocated event. Lalu untuk Kubernetes Batch and Happy Day itu ada di Thursday di bulan Mei, half day event, dan untuk CFP-nya close di tanggal 7 Maret. Jadi ini masih ada waktu buat teman-teman yang berminat, masih bisa banget buat submit CFP-nya. Mumpung masih ada waktu, jadi bisa langsung aja submit. Lalu kita juga ada Kinative Con itu di Thursday tanggal 17 Mei dan sama aja di tanggal 17 Mei dan juga tapi untuk CFP-nya itu di close di Maret tanggal 11, jadi teman-teman bisa langsung aja submit mumpung masih ada waktu. For the first talk is from Srinivasa Vasu. He is from Solution Engineer at Yugabyte and he will bring topic about distributed service on Kubernetes. Is it boon or curse? So I will bring up the Srinivasa to the main stage. Hi. I think you still mute.
Hello everyone. Good evening. Selamat malam. Good to virtually meet all of you. Hope everyone is able to see my
Okay.
screen. Shall we get started?
Okay. I think my connection or what? Yeah. Oh, okay. Yeah. Clear. Okay. So, are you ready?
Yeah, can you hear me?
Okay. I think I think we can start. Uh,
Hello. Yeah, thank you so much. Good evening, everyone. Salamat malam. I hope everyone is staying safe. Good to virtually meet all of you again. Good to be back again. I'm Srini. Today's session is on, is it a boon or curse to run stateful data services on Kubernetes, right? So in the next 30 minutes or so, I'm going to go through in terms of what are the good usage patterns, advantages that you have in terms of running stateful applications on Kubernetes, and what are the challenges associated with it as well. You must be wondering, why am I showing Kubernetes momentum in a CNCF meetup, right? This is just to give you a perspective of the adoption of Kubernetes running containerized application in production on top of Kubernetes, right? So over these years, if you look at the adoption of Kubernetes in production between 2016 and 2019, it has grown a lot, right? The adoption of running containerized applications in production on top of Kubernetes in general is growing year on year. And it's a win-win game across the spectrum, right? If you look at be it developers or SREs or DevOps engineers, everyone has gained a lot of benefits in terms of running containers in production on top of Kubernetes, right? Now, Kubernetes has come a long way. What was largely seen as a containerized orchestration engine to manage a fleet of stateless applications at scale in production. Now, Kubernetes has become a kind of a de facto ubiquitous API engine that abstracts away a lot of infrastructure related resources, right? If you look at the adoption of Kubernetes today, a lot of cloud providers have built native capabilities on top of Kubernetes, wherein which you can consume cloud native services, cloud provider native services via Kubernetes API, right? And a lot of enterprises, vendors have started to ride upon the powerful API constructs of Kubernetes to build their own services as well, right? Now, the obvious question is, can we run, is Kubernetes mature enough to run stateful applications in production or not, right? A simple answer would be yes, but a more pragmatic answer would be like, it depends, right? It depends upon your use case. It depends upon your team composition. It depends upon the maturity. It depends on many other things as well, and keeps it goes on and on, right? And industry veterans, SMEs, advocates have their own takes and thoughts in terms of running stateful data services on top of Kubernetes. If you look at the maturity of Kubernetes 3 years ago, it largely seen as a runtime to manage stateless services only, right? It was not easy to run stateful services on top of Kubernetes, but the runtime has evolved a lot over these years, right? Stateful resources have become a first-class citizens today. You'd be able to run stateful applications on top of Kubernetes, right? The momentum is shifting. It has become a so-called ubiquitous platform that you get to see everywhere. And every vendor, every enterprise is trying to bet on the powerful API construct of Kubernetes to run their services across different clouds, right? And from a data ecosystem standpoint, the data ecosystem is also evolving as well. You see Yugabyte there, Yugabyte DB there. So where I come from, and then you'll see other well-known data services like Postgres, Cassandra, Elastic, Greenplum, Mongo, and so on and so forth, right? Now, the focus of this session is, I'm not going to tell you whether you should run stateful applications on Kubernetes or not, right? The intent of this talk is more about the advantages, the benefits that you get if you decide to run your stateful data services on Kubernetes. And at the same time, what are the challenges that you have to deal with, right? If at all, if you decide to run your stateful services on top of Kubernetes, these are the areas that you have to watch out for. You need to be better prepared if you decide to run the stateful services on top of Kubernetes, right? Let's go through the first part. The first part focuses more on the advantages associated in terms of running your stateful data services on top of Kubernetes in production, right? And this is no brainer. The obvious advantage is better resource utilization. Kubernetes scheduler is very powerful. When you deploy your applications to Kubernetes, it looks at your application definition. It looks into the cluster utilization, how well how many number of nodes in the cluster, how each and every node is utilized, and available spaces. And then you probably would have defined n number of policies in terms of how the resources need to be distributed and scheduled across the clusters, right? The scheduler looks at all these things and quickly takes this dynamic decision of placing your application in the entire cluster footprint, right? And it does its best in terms of how to distribute your applications across. And when you add new nodes, or when you take down one node or a couple of nodes from the cluster, it again does its best in terms of moving across your workloads in the cluster's overall footprint, right? And if the intent is to build a multi-tenanted database as a service, it's easy to do. It again depends on whether you need a logical isolation through namespace level isolation, or if the demand is more like if you had to build tenant local database, you'd be able to build it with Kubernetes, right? Thanks to all the automation and a lot of infrastructure as code services, you can quickly spin up your own Kubernetes cluster, and then you can bring up your own data service on top of it as well. Again, it depends on the applications and the nature of the applications that you deal with. If the intent is, if your microservices demand you to have its own boundary, own local data service, then you have to build tenant local Kubernetes cluster, or you'd be able to build that logical tenancy model where a single cluster could be shared with multiple DBaaS instances as well. And the thing that you need to watch out for is stateful services generally don't like noisy neighbors. So if you have stateful data service plus very busy stateless service in the same Kubernetes cluster, that probably won't gel together, right? So you have to think about keeping your busy stateless service in its own Kubernetes cluster. So that is one thing that you have to keep in mind as well. And dynamically changing your compute and memory resources. That's one of the advantages that you get with Kubernetes. It's just a single command to change your resource requirements on the fly based on the requirement, right? Based on the demand, if you have to make this real-time decisions in terms of changing the footprint of your data service on the fly, you'd be able to do it easily with Kubernetes. Again, thanks to all the automation tools. If you're adopting GitOps model, you'd be able to continuously monitor all these metrics, and then you can make the changes on the fly in the runtime cluster, right? So scale out, scale down, scale up, and all these things are, it's just a single command away in terms of getting it done with Kubernetes. That's very valuable from a self-service, DBaaS as a service model standpoint. If you have to do it on a traditional infrastructure, it used to be operationally intensive once upon a time, but those things also have been automated today. But doing it on top of Kubernetes is more like a bliss compared to doing it on top of a traditional infrastructure, right? And portability between different infrastructure providers, that's one of the promises of Kubernetes. Kubernetes being the core runtime engine that allows you to move your workloads across different infrastructure providers. But what you have to keep in mind is, though the core runtime looks the same, but not every distribution of Kubernetes is one and the same, right? If you have to operate Kubernetes as an enterprise-grade runtime platform, Kubernetes itself is modular, right? It does not come with all the things that you need to operate it as an enterprise-grade platform, right? you still have to plug your CNI implementation, CSI implementation into the core Kubernetes runtime. So GKE distribution is quite different from EKS, AKS, self-managed Kubernetes, bring your own Kubernetes, right? Those are all the things you have to watch out for. How we have created your persistent volumes, how we have created your networking related services, and so on and so forth. So when you move your workloads across different clouds, these are all the things you have to always watch out for. That's where we often make some mistakes, or we often would have challenges in terms of moving the workloads across the clouds. Out-of-the-box infrastructure orchestration, which is another powerful construct of Kubernetes in a distributed system. Given the nature of the distributed services, your pods can crash, your pods can go down randomly, and Kubernetes does its best, right? So the reconciliation loop of Kubernetes ensures that your actual state is always same as the desired state. It tries its best in terms of bringing your cached pod instances automatically, and it makes sure that the instances are spread across the fault domains in the cluster, and so on and so forth, right? And you can leverage things like affinity, anti-affinity rules to ensure that resiliency factor, so that you'd be able to distribute multiple instances of the same application across different fault domains to have the resiliency built at the runtime layer itself. Automating day 2 operations. This is one of the unique value propositions of Kubernetes, thanks to its CRD and controller-based operator pattern, which does the human operator work, right? You write your own controllers that would control most of your day 2 operations, like rolling out upgrades to your service instances, initiating backups, and so on and so forth. This is very valuable from an operational standpoint, right? That's where most of that time is being spent by the human in terms of managing in terms of keeping up with the SLAs of your services. All these things are today transparently managed through operator-based bot pattern, where you can literally code the behavior of how to, roll out service-based upgrades in a rolling upgrade fashion whenever, and based on the nature of the workloads, based on the nature of the traffic, you'd be able to make runtime decisions in terms of when to scale out, when to scale down, and so on and so forth, right? And the next part is the part 2 of the session is more on the challenges that you have to deal with, right? The downsides of, I wouldn't say downsides, so these are all some of the hard problems that you have to deal with if you decide to run your stateful data services on top of Kubernetes, right? The first and foremost challenges, as I said before, these are some of the fallacies of distributed computing, right? Your pods can crash randomly. Again, it depends on how you have defined your disruption budget, and so on and so forth, how you have defined your policies and whatnot, right? Priority, whether it's guaranteed resource quality of service or burstable quality of service and whatnot, right? And based on that, pods can crash. If that's been the case, there will be some disruption to your traditional data service. So if it's a single node RDBMS system, stateful data service that you run it on top of Kubernetes, in case if that instance crashes for some reason, maybe some operational issue or manual error, then there will be some disruption to your production service, right? So that is something that you have to keep in mind, right? So one of the ways to mitigate that problem is to look at a distributed database, right? So that you'll have multiple instances of the service itself. Even if one or two instances go down because of some reason, you'll still have the service intact, and there won't be any disruption to your read and write traffic, right? So the service would continue to serve the read and write traffic without any business disruptions. Local versus persistent storage. This is another interesting thing. So if you're when it comes to stateful data services, performance is paramount. If you need to use local storage, that's where you get better performance compared to a network attached storage. But the challenge with local storage is if you are consuming host volume in a single node traditional RDBMS system, then the underlying scheduler is totally unaware of the host volume, right? So if the pod, if the single instance of your application gets rescheduled on a different node, you lose the data. You'll not have the data there. Again, host volume is not recommended to use it in production because of the security related challenges that you have to deal with. But if you want to use local persistent volumes, the one downside of local persistent volume is, again, if the node crashes, if you lose the node, or if the storage volume itself is corrupted, you lose the data because it's local to the node. That is the challenge that you'll have with a single node system, right? And when it comes to persistent storage, persistent storage, it's easy to provision on a cloud provider based infrastructure like EBS, Google PDs, and so on and so forth. It's very hard to do it. To an extent, it's hard to do it in a non-prem infrastructure. You have to depend on some proprietary software to enable the replication of data at the storage level, right? So one of the ways to mitigate this issue is whether you want to use local storage or persistent storage. Distributed database is one of the options because in the case of distributed DB, the data is distributed and replicated across multiple nodes in the cluster. So even if you had to use local persistent volume, if the node is lost or the storage is corrupted, you still have the copies of data in the other surviving instances so that you can initiate re-replication process to ensure that the actual number of copies is same as the desired limit, whatever you have specified, right? So that's one of the ways that you can mitigate this issue, right? So though the underlying runtime gives you some of the advantages, but to mitigate the shortcomings of the single node system, you can look at alternative of a distributed DB to distribute and replicate the data at the database software layer itself, right? And need for a load balancer. This is something that you have to keep in mind as well. This we spoke about in the previous slide as well, right? So the way how you expose your services would depend on where exactly you run your Kubernetes distribution. In the case of cloud, consuming L4 load balancer is not a big deal. Those syntax and semantics are honored, so you can expose a service of type load balancer. But you'll always have the challenge in an on-prem based Kubernetes distribution, or bring your own Kubernetes distribution, right? So if the networking layer is not well integrated into your distribution, then creating a load balance service would be challenging, right? So operationally intensive, you have to create it outside of the platform and then make sure that you have the network level routing rules set up properly to route your request from the load balancer layer to the to the actual running instance itself, right? That's one of the challenges that you have to keep in mind, right? And networking complexities are there, right? This is at this point of time, this is more of a limitation of Kubernetes. Because if you look at the consumption model today, we have started looking beyond a zonal deployment of Kubernetes, right? Today, from a resiliency standpoint, we want to run context-aware Kubernetes across regions, right? Today, the service discovery happens within a cluster. You can't discover services across clusters. There are some initiatives that are going on to enable the feature so that you'd be able to discover services across clusters. Google GKE recently introduced a feature called multi-cluster services, through which you would be able to do service discovery across clusters, right? So this is something that's very hard to do with Kubernetes today. So if your deployment pattern demands you from a resiliency standpoint to distribute your data service across regions, then it's very hard to do it with Kubernetes, right? So since the discovery part is cluster local, you have to rely on multi-cluster services. If it's on GKE or if it's on some other cloud, probably you have to do DNS chaining and other third-party services to get that implemented, right? So that's one thing that you have to keep in mind, right? So these are the 5 benefits on the left. Those highlighted in green are like better resource utilization, dynamically scheduled, dynamically changing your resource requirements, portability between different infrastructures, and out-of-the-box powerful orchestration, fully automated day 2 operations, and so on and so forth, just to name some of the important things, right? And at the same time, on the right, what you see here is there are certain limitations that you have a way to mitigate those limitations. Instead of running a single node RDBMS data service, you can look at a distributed data service like Yugabyte or something of the same nature, right? to run it on top of Kubernetes. So pod failure, local versus persistent storage related challenges can be easily mitigated with a distributed database, and rest of the things are applicable in general for all of your stateful services. That is something that you have to keep in mind, and you have to watch out for if you decide to run your stateful data services on top of Kubernetes, right? And Yugabyte DB is one of the open source projects in the broader Cncf umbrella. It's a distributed database. It's a cloud native, open source, fully open source, Postgres API compatible, strongly consistent OLTP database, right? Yugabyte has a lot of similarities with Kubernetes. Similar to what Kubernetes does for resources, Yugabyte DB does the same thing for data as well. Any distributed system in general, the underlying underpinning core principles will be more or less the same. If you look at Kubernetes, if you look at Yugabyte or Kafka, all these distributed systems, the core principles would be more or less the same. But the way how those underpinning principles are implemented, that would differ between the products, right? As you can see, as I stated before, Yugabyte DB carries a lot of similarities with Kubernetes. Similar to Kubernetes, it has got two distinct processes. The master process is responsible for managing the metadata information, similar to API server and etcd, and it's responsible for doing administratively related tasks as well, right? So it does not sit in a critical data path. And tserver service is something similar to Kubelet and rest of the other services that are responsible for managing the lifecycle of your application. In a similar way, tserver service is responsible for managing the lifecycle of the data, right? So like how you deploy an application to Kubernetes by defining a deployment manifest or stateful manifest, where you specify the number of replica instances for the application, where exactly the image needs to be pulled from, and how exactly the instances need to be deployed across by defining an affinity rules, anti-affinity rules, and so on and so forth. Right? In a similar way, we would do it in Yugabyte DB for the data, right? So while creating the cluster, we'll define the number of replication factors. So the Yugabyte DB ensures that every data that you write to the system, every block in the storage would get replicated based on the defined number of based on your replication factor, right? So, and at the same time, under the hood, it ensures that the actual copies of the data is always in line with your desired copy, right? In case if the node crashes, it reinitiates, it rebalances the data across the surviving nodes in the cluster, and so on and so forth. Similar to what Kubernetes does for your deployment manifest or your application definitions, right? The architecture of Yugabyte DB on top of Kubernetes, like I said, it consists of two different processes. We'll deploy both master and tserver processes as stateful objects. So you'll have, from a resiliency standpoint, you'll have multiple instances of master and tserver. These multiple instances would form a quorum, and there will be one instance that's from a master standpoint would be responsible for processing read and write traffic, and rest of them would closely follow the master instance as well. And tserver also follows the same principle. Under the hood, a table gets when you create a table in Yugabyte, it gets physically sliced into multiple shards, and each shard would get into a distributed consensus quorum group, and you'll have a leader and you'll have followers in the quorum group. And in a given cluster, we'll find n number of shards, and each shard would follow the same principle, right? And within a quorum group, there will be one write owner that would be responsible to process your read and write traffic, and rest of them would closely follow the quorum leader. And in case if the quorum leader crashes for some reason, then one of the followers would get elected as the leader and it continue to function without impacting your user traffic or business traffic, right? So Yugabyte DB, you can find the deployment pattern in the documentation, docs.yugabyte.com. Helm-based deployment plus Kubernetes operator-based deployment, both are supported, certified, so that you can try out both the things to run Yugabyte DB on top of Kubernetes. And we have also tested and certified Yugabyte DB to run on different flavors of Kubernetes as well, whether it's AKS or EKS, GKE, or bring your own Kubernetes. All these various distributions are tested and certified, right? From a demo standpoint, I know we are right on time. So in the interest of time, I'm not going to run Yugabyte DB on Kubernetes now, but I just want to quickly show you one of the ways that you can get started with Yugabyte DB. So what I've done is, I'm not sure how many of you are familiar with Gitpod. Gitpod is more of a cloud-hosted solution. It's one of the ways where you can improve the developer experience, right? You can quickly get started with your development right in your browser console, where all your dependencies can be specified in a Docker image, and when the container gets created, you have a fully integrated development environment to get started quickly, right? In a similar way, I've used Gitpod. So I'm going to show you a quick demo in terms of how we can quickly spin up a distributed Yugabyte DB cluster on one of the Gitpod powered containers, right? So let me go ahead and launch the database. Give it a couple of seconds, it's initializing it. So in the meantime, if you look at the definition here, this is the Docker file that we have defined. So we are just defining the version of the database that we want to spin up, where to download it, and then few database specific things in order to run multiple instances of it, right? And it's just pulling the container image. So what Gitpod does is, based on the definition, it's going to create the container image, and it's going to spin up a cluster. It's going to spin up a Yugabyte DB cluster in its own container, right? So again, Gitpod runs on top of Kubernetes. It's one of the ways that you can quickly get started with Yugabyte DB without installing anything in your local workstation, right? It's just a browser window where you can create everything on the fly, right? So it has created the cluster. So if you look at, it's throwing some notifications. It's more about how exactly things are running. So in the sense, if you look at the console window here, in this case, I've spin up a cluster of 3 nodes, and each of the node provisioning has happened in its own terminal space. And finally, I've applied some placement policy similar to what we do with Kubernetes for applications. I've applied the same thing for the data as well. And finally, it has taken me to a shell window. This is nothing but the window to connect to the database itself, right? So before creating some tables there, I just want to show you the GUI part of it. As I said before, everything is accessible via the browser interface itself. So if you want to integrate your microservice through Gitpod, then you can have your source code part of the same definition itself, so that you'd be able to do everything via the single integrated interface, right? Moving on to the UI part. So this is a cluster with 3 nodes. If you look at the number of P servers, we have created a cluster with 3 nodes. And these 3 nodes are basically distributed across different zones: AP South 1, 1A, 1B, and 1C. And even if I look at the cluster definition, this is something that you'd be able to relate to, right? So this is how we deploy applications to Kubernetes, right? This is the placement policy, and we have specified the number of replicas to be 3. There has to be always 3 copies of the data in the cluster, and this is how I want the copies to be distributed across, just to ensure that the copies are distributed across your fault domain. So in this case, we have created a cluster with 3 fault domains, so that each domain will have at least 1 copy, so that even if you lose an entire domain, you still have 2 copies intact, so that your cluster would continue to operate, right? So just to make sure that everything works, so if I want to create a table, I can quickly try it out. Create table demo with, let's say, 2 columns. The table is created. If I go back to this UI, you'll be able to see the table here. And this table is, if you go back to the tablet servers, you'll see that that table is being distributed across 3 different nodes. So that's the reason the replication factor is 3. That's why you see 3 copies of this table, and each node being the leader for one of the shards. That's how the read and write requests would be distributed across multiple nodes in the cluster. So that's pretty much on the demo part. If you guys want to try it out, the repository is available. You can fork it and then you can try it out on your own, right? And going back to the final few slides, just to wrap it up. From a performance standpoint, if you want to use local storage, then make sure that today you can't dynamically provision local storage, though you have some references, but still you have to create your persistent volumes upfront to be exposed as volume claim templates for your stateful workloads. In the case of remote storage, you can leverage dynamic provisioning, so you'll be able to provision the storage on the fly, and make sure that you leverage affinity and anti-affinity rules just to ensure that the stateful instances are distributed across your fault domain, so that even if there is a node failure in a multi-zone deployment, or if there is a zone failure if there is a zone failure in a regional deployment, your instances would be distributed across the fault domains, so that there will not be any disruption to your running service. Thank you so much. That's it from me.
Okay, great. Interesting topic, yeah. And yeah, I think we can do the next talk. And please don't leave quickly, Srini, because we have another Q&A session. Thank you for your talk.
Thank you. Terima kasih. Thank you.
Okay, terima kasih. Okay. And the next, wait. Okay, wait. Okay. For the next is untuk selanjutnya kita ada dari Pak Akbar dari Senior Site Reliability Engineer Flip ID yang akan membawakan materi mengenai KPT for Kubernetes. Oke, saat ini kita udah ada Pak Akbar. Udah bisa dimulai, Pak?
Oke, udah bisa, Mas.
Oke. Mungkin bisa di-share dulu screen-nya. Oke, great. Oke, silakan bisa dimulai, Mas. Waktu dan tempat dipersilahkan.
Oke, terima kasih buat kesempatannya, Mas dan tim Cncf Indonesia. Assalamualaikum warahmatullahi wabarakatuh. Selamat malam semuanya. Kali ini saya akan membawakan topik tentang Kubernetes, relate dengan Kubernetes, yaitu sebuah package manager, yaitu KEP. Secara ejaan KPT, cuman secara pengucapannya dibaca KEP. Sebelumnya, salam kenal semua, nama saya Akbar. Saat ini saya bekerja di Flip sebagai Site Reliability Engineer. Saya juga aktif menulis di web pribadi saya di sekolahlinux.com. Juga sebelumnya saya sempat di beberapa startup juga, seperti di Kantar.ai, di tiket.com, dan juga di beberapa IT konsultan dan internet service provider ya. Nah, sebelum kita membahas lebih jauh soal KEP, saya akan coba introduce dulu apa sih itu KEP. KEP itu sendiri kan, KEP itu sendiri sebenarnya dibuat oleh engineering Google. Nanti mungkin setelah ini Mas bisa coba kunjungi websitenya. Di situ kebetulan dia untuk GitHub-nya sendiri under Google Container Group itu ya. Nah, CAP sendiri ini terinspirasi oleh IPT. Mungkin kalau yang biasa pakai Linux, Ubuntu atau Debian udah pernah tahu IPT, package manager untuk install aplikasi di Linux. Cuman kalau si CAP ini sendiri fokusnya untuk Kubernetes. Nah, si CAP ini sendiri adalah sebuah package manager yang
Bisa, Mas?
diperuntukkan untuk
Bisa di full screen layarnya.
bisa dia
Full screen, sorry.
sorry.
Oke.
Ya untuk
Oke.
Oke.
Thank you, Mas.
Ya untuk CAP ini sendiri digunakan untuk memanage Kubernetes resource seperti manifest yang ada. Di antara solusi yang diberikan oleh CAP itu seperti CAP fetch, CAP display, CAP customize, CAP update, CAP validate, dan CAP apply. Kurang lebih fitur-fitur ini mungkin ada di tool sejenis seperti Helm ataupun di customize itu. Nah, tadi saya sempat bilang fitur-fiturnya sendiri kurang lebih mirip dengan yang ada di Helm ataupun di customize itu. Kalau di Helm ada versioning, maka di CAP juga kita ada versioning. Cuman di CAP sendiri untuk versioningnya pakai GitOps. Terus secara templatingnya juga mirip-mirip dengan Helm. Cuman untuk implementasinya lebih mudah. Nggak sesulit Helm kan, karena kalau di Helm kan kita pakai golang template ya, pakai globe pattern gitu. Nah, kalau di CAP ini nanti ada metodenya sendiri untuk menentukan mana value yang akan di-replace oleh si CAP file ini gitu. Nah, kemudahannya sendiri menurut saya sih hampir sama seperti ketika saya menggunakan customize ya, cuman jauh lebih simpel gitu kan. Kalau di customize kita harus ngebuat base template-nya dulu, setelah buat base template baru kita ngebuat template overlay-nya gitu. Nah, kalau di CAP ini kurang lebih mirip seperti di Helm. Jadi ada CAP file ini bentuknya kurang lebih mungkin seperti kalau diperumpamakan tuh seperti Helm value. Nah, cuman nanti ada template-nya lagi gitu. Untuk bisa menjalankan CAP sendiri, ini harus terinstall, ada Docker di environment tempat kita menjalankan CAP, juga ada Git. Kenapa CAP sendiri saat ini masih required sama Docker dan Git. Namun untuk kedepannya nanti dia akan bisa standalone. Jadi untuk saat ini sih belum bisa seperti customize atau Helm yang bisa standalone ya, maksudnya bisa tanpa tergantung dengan apps lain gitu. Karena cara kerja CAP itu nanti untuk menjalankan function-functionnya itu dia memanfaatkan si Docker image gitu yang akan di-pull, dan kemudian nanti si Docker image ini akan fungsinya akan digunakan oleh si CAP gitu. Nah, secara workflow CAP ini sendiri terbagi menjadi dua secara garis besar, yaitu CAP get dan CAP apply gitu. CAP get ini kita seperti Helm get value atau Helm inspect value atau Helm download package-nya gitu. Baru setelah itu kita edit value-nya. Cuman kalau di Helm kan ketika kita Helm apply, otomatis dia akan langsung apply juga ke mana, ke kita punya Kubernetes cluster gitu ya. Kalau di CAP nggak, kalau di CAP itu dia harus di-render dulu. Jadi dia ada semacam proses lagi untuk merubah template-nya gitu. Jadi sebenarnya ketika sudah melakukan CAP render, nanti itu udah bisa langsung dijalankan gitu, pakai kubectl apply. Beda dengan customize yang harus pakai customize kubectl apply minka apa gitu kan. Kalau di CAP bisa pakai kubectl apply aja gitu, karena sifatnya dia tuh cuman ya mereplace atau nge-override si value yang udah ditentukan. Nah, lalu jika sudah CAP get, edit, dan render, selanjutnya itu CAP apply. Sebenarnya walaupun pakai kubectl apply bisa, tapi di cap apply sendiri di cap CLI sendiri ada fitur untuk apply. Jadi ada setelah di render kita menjalankan cap initialize, cap preview ini kayak dry run dulu. Jadi kita memastikan ngevalidasi apakah manifestnya sudah benar, terus nanti kalau terdeploy ke cluster itu no issue gitu. Nah, baru habis itu bisa di-apply ke cluster. Setelah di-apply di cluster, baru ada juga fitur cap CLI untuk observe. Jadi untuk memantau apakah setelah di-apply ini apakah ada isu atau enggak nih di clusternya gitu dari deployment-nya. Nah, tadi saya sempat bilang juga cap ini mendukung versioning. Nah, kalau di cap sendiri untuk versioningnya kita pakai Gitpod, bisa multi repo ataupun monorepo gitu. Kurang lebih template-nya seperti ini, kayak Gitpod biasa, git tag, git push. Cuma nanti ketika kita mau nge-clone-nya itu nggak pakai git clone, ada namanya cap CLI-nya itu cap packet get. Jadi nanti dia hanya mendownload cap file serta template manifest-manifestnya aja gitu, tapi tidak bersama folder.git-nya gitu kan. Biasanya kalau kita pakai git clone kan otomatis akan include sama .git-nya gitu. Nah, ini enggak. Nah, di cap sendiri ada banyak function, disediakan banyak function. Dia udah membuat kayak semacam katalog gitu. Jadi ada katalog untuk nge-replace namespace atau nge-replace variabel parameter-parameter yang emang udah ada di manifest gitu. Nanti kita bisa set pakai setter namanya. Terus ada juga untuk menambahkan label, menambahkan prefix, suffix gitu. Juga ada validatornya. Jadi setelah nanti kalau kita setelah render itu biasanya pas mau apply itu nanti ada validasinya dulu dari si cap untuk memastikan kalau ini secara struktur manifestnya udah benar gitu. Nah, untuk katalognya sendiri bisa dilihat di websitenya. Jadi ada beberapa jenis function, ada tipenya, ada validator, ada mutator, ada name prefix, dan ada yang lainnya juga. Cuman yang saya tampilkan di capture gambar ini cuma segini, cuman ada banyak. Selain itu juga kita bisa ngebuat custom function gitu. Pakai kalau nggak salah mereka ininya kita bisa buat custom function sendiri untuk si cap ini gitu, sesuai dengan kebutuhan yang dibutuhkan gitu. Nah, ini kalau kalian bisa lihat di sebelah kiri ini ada contoh cap filenya, sedangkan yang di sebelah kanan adalah manifest Kubernetes-nya atau kind deployment dari si Kubernetes. Nah, pada cap file ini bisa dilihat pada parameter pipeline, terus mutator. Nah, di bawahnya itu menggunakan Docker image. Makanya kenapa tadi saya bilang ini masih required-nya Docker gitu. Butuh Docker untuk bisa menjalankan cap gitu. Karena dia menggunakan image untuk menjalankan fungsinya itu gitu. Jadi kita set variabelnya, misalkan variabelnya replika, terus image tag, terus ada juga function untuk set label, dan macam-macam function yang tadi ada di katalognya gitu. Di sini cuma 2. Nah, lalu bagaimana implementasi di manifestnya? Nah, di manifestnya ini kita bisa set setternya gitu. Misalkan contohnya di replika gitu. Replikanya ini kan di sini cuma 1 ya. Saya set cap setnya itu cap setternya itu nanti akan di-replace oleh variabel replika yang sebelumnya saya set di cap file gitu. Begitupun dengan image kontainernya. Nah, mungkin langsung demo aja kali ya, biar lebih. Ini aku switch dulu ya, Mas ya.
Oke, Mas, nggak apa-apa. Oke.
Nah, sebelumnya di sini saya udah sempat ngebuat sampel service yang akan nanti di deploy. Jadi di sini ada repo saya, cap, terus di sini udah saya buat ada 2 tag, versioningnya udah saya buat 2 gitu. Terus gimana sih cara nge-fetch-nya gitu atau nge-clone si cap filenya. Jadi untuk proses get-nya sendiri ini formatnya itu GitHub URL-nya cap, terus habis itu baru dilanjut ke folder dari service yang akan kita download. Di sini saya namain service A ya, terus baru tag-nya ini v01 gitu. Nah ini saya coba. Oh. Ini contohnya, tadi saya nggak tahu yang kenapa gagal di yang saya buat, sebelumnya berhasil. Nah ini contohnya misalkan kita mau download package Nginx gitu. Nah ini kita bisa langsung download aja, ini sampelnya. Jadi nanti pas kita download, kita fetch, kita get package-nya, get package-nya. Terus kita explore. Ini dia ada fitur Explorer, jadi kayak semacam 3D Linux, cuman bisa kelihatan. Jadi masing-masing file itu bisa ketahuan dia ini jenis filenya apa gitu. Misalkan ini manifest resource deployment dengan name-nya itu my-nginx gitu, ataupun manifest file service name service.yaml, child-nya service, naming-nya my-nginx service. Ini contoh yang tadi ada di slide, kurang lebih kayak gini, replika, terus image tag-nya yang udah kita tentukan gitu. Misalkan kita mau update, nanti bisa diganti, terus menambahkan label environment dev, lalu kita pakai validator untuk memastikan apa yang udah di render itu benar gitu. Ini kita coba aja kan. bisa ngelihat if-nya. Kalau udah kita coba add fn render. Nah ini cukup menjalankan cap fn render, nanti dia akan mengcustom manifest template-nya yang deployment YAML dan service YAML. Kalau kita coba git diff, nah ini kita bisa lihat ada perubahan pada template deployment YAML-nya yang tadinya replikanya 1 berubah jadi 3, terus image engine X juga tag-nya berubah, dan ada penambahan label environment dev. Nah, lalu selanjutnya di workflow-nya itu kan kita harus melakukan init ya. Init sendiri itu untuk menggenerate file apa aja sih nanti yang akan di-apply gitu. Nanti akan list filenya itu akan dimasukkan ke dalam si cap filenya itu. Kita pakai. Ini ada penambahan parameter yang tadi setelah kita menjalankan cap live init, jadi ada penambahan kayak namespace-nya apa, nama inventory-nya apa, inventory ID-nya apa. Nah, inventory ID ini di dalamnya ini sebenarnya dia menyimpan data kayak di sini tuh file apa aja yang nanti akan dijalankan ketika kita mengeksekusi cap apply gitu. Jadi kalau ada penambahan service baru, ada manifest baru, tiba-tiba kita ngebuat, terus kita jalanin cap apply, ya nanti yang akan dieksekusi cuman yang sebelumnya ke-register aja gitu. Sebelumnya kita nge-register pakai cap list ini. Terus kalau udah. Nah ini kelihatan nih ada satu yang file. Kayaknya sih si readme-nya mungkin ya, karena harusnya nggak ada readme di dalamnya. Terus setelah itu baru kita jalankan kubectl cap live apply. Ini sebelumnya saya sudah pasang ini, kita coba cek belum ada. Nah ini dia otomatis ketika menjalankan cap live apply dia akan langsung menjalankan seperti kubectl apply gitu, manifestnya. Ini biasanya akan ditunggu dulu sampai ini apa statusnya ready, baru dia akan selesai. Sepertinya butuh waktu. Nah, setelah cap live apply-nya berhasil, kita juga bisa melakukan kayak observe gitu untuk memastikan bahwa service yang udah di-deploy itu berhasil jalan semua gitu. Kita bisa langsung pakai cap live destroy gitu. Seperti kita kayak pakai helm delete nama helm installnya. Nah, ini udah berhasil. Tadi ini yang file kayaknya sih si file readme-nya ini harusnya nggak ada file readme di sini. Terus kita bisa pakai live status buat observe ya. Nah, bisa kelihatan replikanya 3 dan oke gitu. Terus kalau kita mau delete juga tinggal live destroy. Lebih gitu. Nah, sebenarnya sendiri fungsinya banyak ya. Terus bisa kita explore juga, misalkan dia untuk nge-replace config map gitu. Jadi kita bisa nge-put config map di dalam cap filenya gitu. Seperti di helm value kan kita bisa taruh config map kan, yang sifatnya tuh kayak file gitu ya. Itu bisa di cap juga. Nanti tinggal implementasi implementasinya aja disesuaikan di cat filenya. Ya, kurang lebih sih itu ya untuk cap dan demonya. Sebenarnya untuk cap sendiri masih dalam apa, statusnya itu masih beta, jadi belum dipublish, maksudnya belum stable gitu, belum ada versi stabilnya, dan ini masih terus dikembangkan sama komunitas dan juga sama engineering Google. Karena sepertinya kalau dilihat dari websitenya dan milisnya juga, dari milis grupnya, ini nanti akan diintegrasikan dengan Google Cloud juga gitu, si CAP ini. Nah, itu aja dari saya presentasi kali ini dan demonya, dan mungkin buat teman-teman kalau ada yang cari opportunity baru, kebetulan tempat saya kerja saat ini sedang membuka kesempatan untuk mencari SRE gitu. Nanti bisa langsung mengunjungi websitenya aja. Itu aja dari saya. Terima kasih, Mas.
Oke, mantap banget untuk materinya, Pak Akbar. Mungkin kita bisa langsung ke next session ya. Itu adalah Q&A. Oke, I will bring up the Srini again. Hello Srini.
Yep.
Okay. We will do the Q&A session. Yeah, and for the first question, I think from Habibur Rahman Sterbini. Okay, may I know how major is Yugabyte operator? And the next, in the terms of the capability level, I think you can answer.
Yeah, I could see Yogi has already responded to that question in the chat window, but anyway, I'll quickly respond to it as well. Kubernetes operator is matured, but compared between Helm and Kubernetes, Helm is well matured and quite tested across different distributions of Kubernetes as well. That Helm-based deployment is one of the ways that you can quickly get started with. We have incorporated some of the automations into operator-based provisioning, but still few features would be missing in operator-based provisioning as well, so which is actively being worked upon.
Okay, great. And I think I have a question from myself, and it's about, I think it's silly question, but yeah. What happens if all the node that keep the replica is done? Is it still be able to recover the data, and what will we do if this happen?
Come again. What is the question? Sorry.
Sorry. What happens if all the node that keep the replica is down, and is still be able to recover the data? And yeah, what will we do if that happen?
Correct. So that's the reason we have to distribute it across the fault domains, right? Assume the worst, right? So we have created a Kubernetes cluster, right? A 3-node cluster. And it's a zonal deployment, right? We have taken 3 nodes from one zone and we have created the cluster. And if you deploy Yugabyte,
Okay.
So if you deploy Yugabyte DB on top of Kubernetes, the instances are going to distribute it across multiple nodes in the cluster. As node being your fault domain, right? Because it's a 3-node cluster and you'll have one instance sitting in each node in the cluster. So if you create a Yugabyte DB cluster with a replication factor of 3, then there will be total 3 instances and 3 replicas, and these replicas are going to get distributed across the nodes, right? So from a deployment standpoint, it is a stateful set-based deployment, and each instance would have its own volume claim template. And the data is instance local, right? So the data would get replicated across the instances through the software layer itself, right? Yugabyte DB does not depend on the underlying storage to replicate the data. So whenever you fire a query, you send a write request to one of the instances, the write gets returned to its local copy, and at the same time, it is sent over to the follower instances as well. So once it gets the hack back from the follower instance, at least from the majority of the instances, then the write gets committed and the acknowledgement is sent back to the client. In that way, you'll always have multiple copies of the data, right? So even if you lose that node altogether, if the node is lost or the storage is lost, still you'll have copies in other instances of the database.
Okay, I see. Okay. Thank you. Okay. Next, I think is for Pak Akbar. Oke, dari Pak Johannes Primanggara, pada use case apa preferable cap ketimbang helm? Mungkin bisa dijawab.
Prefer ya untuk cap sendiri, kapan sih kita menggunakan cap atau kapan kita menggunakan helm itu sebenarnya tergantung preferensi masing-masing atau tergantung style masing-masing gitu. Sebenarnya nggak ada waktu yang spesifik kapan harus menggunakannya, tapi lebih ke kalau pengen simple ya udah saya pakai cap aja gitu. Karena kan kalau kita pakai helm biasanya kan harus tahu nih gimana cara ngebuat helm filenya, terus harus tahu block pattern-nya, go template-nya seperti apa gitu. Karena kan kalau untuk orang-orang yang mungkin belum familiar itu akan jauh lebih sulit si cap ini, yang menurut saya jauh lebih mudah untuk implementasi.
Oke, noted. Oke, next ini ada dari Pak Gofrendi. Can we combine KPT with Helm chart? Example, using KPT to replace Helm value. Is that a common practice?
Ini kayak di Inception ya. Saya nge-replace untuk nge-replace. Ini belum pernah dicoba sih, Pak. Ini saya belum coba sih. Harusnya kalau Helm value-nya itu YAML kemungkinan sih bisa ya. Cuma saya sendiri belum coba itu untuk coba replace value yang ada di Helm chart gitu.
Oke. Ya. Oke. I think I have question. The last question from me to Mr. Srini is about the PVC. The PVC that used in the Yugabyte. Is there any requirement, specific requirement for we using PVC for the deployment?
No, you can. It again depends on your performance-related requirements. For example, compared to local storage versus network-attached storage, the local storage instances are going to be performant, right? So you can use both local storage as well as network-attached storage. Not an issue. Since the replication is handled in the software layer, anyways, even if you lose your local storage, persistent volume is still network-attached still have it, even if the instances gets rescheduled. So there is no challenge there. You can use both local persistent volume as well as network attached persistent volumes as well.
Okay, great. Thank you for the answer. Okay, I think it's enough for the Q&A. Or the audience have another question. Okay, I think it's enough. Thank you for Pak Akbar and Srini. The last I think from Mr. Gofrendi. Does Yugabyte support and hot cold storage? For example, all data will move to the HDD instead of SSD. Yeah.
No, we don't support that today. In the sense, we don't have a way to move your historical or slightly outdated data to a cold storage automatically. That's not possible today.
Okay. Noted. Okay. I think it's enough, and thank you for Pak Akbar and Srini for the great topic and the matter. For the great topic, and I think it's enough, and have a good time. Thank you.
Have a good time, all of you. Thank you so much.
Okay. Thank you. Yeah. Okay. Next. Oke, next. Oke, kita ada survei form. Jadi teman-teman tolong bisa ke sini. Wait. Bisa di scan ataupun mungkin ke online.kubernetescommunity.id /survey dan tolong diisi untuk surveinya. Ini berguna untuk kita bisa mengetahui gimana kekurangan dan apa yang perlu kita improve untuk next meetup. Jadi ya teman-teman bisa tolong scan untuk surveinya. Oke. Next for the announcement. Ya, jadi jika teman-teman ada ini ide atau meetup topik atau mau one company you wish for to give a talk atau ada interesting project, bisa langsung aja submit ke sini ke GitHub. GitHub Protective ID Meetup Issue. Ya, feel free aja langsung buat create issue aja dan oke. Ya. Oke, wait. Oke, untuk link Oke, untuk link surveinya bisa ada di sini ya, di komentar. Oke. Dan juga tolong join ke Telegram kita, terus ada meetup.com dan ada juga GitHub kita di Cloud Native ID Meetup. Mungkin sekian dari saya. Lalu jika ada kata salah saya mohon maaf. Dan sampai berjumpa di next meetup bulan depan selanjutnya. Oke, thank you semuanya. Have a good day. Thank you all.